The title that I have chosen for today's webinar is It Just Ain't So. And we are going to be talking about a variety of what I call welding myths. Welding myths that the structural engineers need to know about. I'm assuming most of my audience fits into the category of structural engineers. My customers, the people who fabricate your steel and erect your steel, they appreciate me reaching out to you because a fabricated structure requires good interaction between all the parties that are involved. And yet sometimes it's my customers that promulgate some myths, and structural engineers need to know that these are myths and understand what the facts are. Now, before I get into myths any further, allow me to explain that oftentimes myths are buried or are rooted in some factual component. Sometimes it's a factual component that just isn't universal in its application. So we're going to try to decipher these, and in the process, I hope you learn a little bit about more about welded connections and what the structural engineers should be doing. Mark Twain once said, "It ain't what you don't know that gets into trouble. It's what you know for sure that just ain't true or just ain't so." And in fact, again, some of these myths have some degree of truth associated with them, but we need to understand when it just ain't so. And that's what we'll be talking about today. There was a popular TV show, I think it's off the air now, of Mythbusters. Well, today we're going to be busting 10 welding myths. Each of these is kind of a standalone. When I get through about half of them, we'll be taking our break, which might be a little bit off of the time schedule that was announced, but we'll get through all 10 of them. Back when I was a young kid, there was the TV show Dragnet. And for most of the audience, I suspect this is ancient history. But the detective, played by Jack Webb, used to say, "Just the facts, ma'am." Well, today I hope to be showing you just the facts so that we understand the important element of these sayings and certainly when they're false. With that as an introduction, let's start with myth number one. The only full-strength weld is a CJP. Now, CJP stands for Complete Joint Penetration Groove Weld. Now, when I say full strength, I'm meaning that the weld develops the full static strength of the weaker of the attached base metals. At this point in time, we're not talking about fatigue, but we are talking about the typical structural connections, statically loaded connections. And there's a myth. And the myth is that the only way I get a full strength weld is to specify a CJP groove weld. Now let's first look at where that's true. Here we have a butt joint, and if we properly detail the weld, if we use the right filler materials, we get the full strength of the attached material out of that groove weld CJP in a butt joint. Everyone on the call no doubt realizes that if I use a single PJP groove weld in a butt joint, I will never be able to achieve the full strength of the connected material. Let's switch from butt joints to T-joints. A CJP in a T-joint gives me full strength of the attached material. However, I could replace the CJP groove weld with properly sized fillet welds. And if the fillet weld sizing is proper, I can develop the full strength of the attached material through this fillet welded connection. So here's the first example of a violation of a myth. It is possible in a T-joint to develop the full strength of the attached material using properly sized fillet welds. Let's go to PJP groove welds and stick with the same T-joint. We can never develop, even with double-sided PJPs, let me make sure I'm clear on that, we can never develop with double-sided PJP groove welds the full strength of the connected material if that's the only weld we use. However, we could add to a PJP groove weld a properly sized fillet weld and duplicate the strength of the attached material. Now in this case we are looking at T-joints, but we could also be looking at corner joints. And as I go to corner joints, I have the same situation.